All right, number 30. Number 30. So we talked about that you have to decide between y equals ab to the x and y equals pe to the rt. Okay, and so on this one, since it doesn't stay continuous, we're going to use ab to the x. Now, you have to be a little bit careful because we got compound and monthly in there, so just be careful when you use that. All right, so y, a, b, x. Now, your teacher might have taught you this a little bit differently, but watch what I do with b and it will be okay. So you invest $3,000, so that's our starting amount, at 6.25% in annual interest compounded monthly. Okay, so what I'm going to do with b is I'm going to do 1 plus, because interest will always add to your account, so 0.0675, and again, if you get those decimals wrong, make sure you take this in your calculator and divide it by 100. Then you'll never get the decimal wrong. Okay, divided by 12. Okay, because compounded monthly. So how long will it take to quadruple your money? That's your x, that's unknown. Now, one thing you want to be careful of is because you took your annual interest rate and divided it by 12, that will give you the number of months. Okay, it's totally fine if you have months in your answer. You just have to make sure that you say months or say years or whatever. Okay, and we got to find, and then we want to find how long it takes our money to quadruple. All right, so quadruple 3,000 is going to be 12,000. All right, so 12,000 equals 3,000 times 1 plus 0.0675 divided by 12 to the x. All right. We're going to eventually need a log because there's a variable in the exponent. So divide by 3,000. Those make 1. And then what do you know? That's 4. 1 plus 0.0675 divided by 12 to the x. And again, I should say again, but the idea is that it takes the same amount of time for your money to quadruple no matter how much money you have. So if you're good, you can start the quadruple type problems right here because there's an imaginary 1 right here, so it's like you start with $1 and you go to 4. It's going to take the same amount of time to go from 1 to 4 as it is from 3,000 to 12,000. So, whatever. Alright, so now we're going to use we're going to log using either base 10 or base E. I'm going to use base 10, so just log of 4. And it really doesn't matter. You can do the problem with natural log and get the right answer. Alright, so I'm log of 1 plus 0.0675 divided by 12 to the x. You've got your variable there. You're going to move it out front. So log 4 equals x log 1 plus 0.0675 divided by 12. Okay. Now these are together with multiplication. So we have to undo that multiplication by division. So log 4 divided by log 1 plus 0.0675 divided by 12. It's going to equal x. So no real tricks when you type this one in. So log 4 divided by log 1 plus 0.0675 divide by 12. Alright, there you go, 247 months. divided by 12 to make it, whoa, I divided by, so divided by 12 to make it about 20 years. Now, again, I'm fine with months on the test. You just have to label it. So that's month.